Okay, what's up, dudes? On this Thursday, the 29th of August, we are cranking up at 10:52, and I'm gonna be coding till 12, so it's about an hour. We're gonna go to the gym after that, and we already took our shower, so I'm gonna be Gucci on that. I can come right back and, well, actually, I have some business I have to take care of today. To go to the notary. So let's pick up where we left off yesterday. We were continuing game testing and debugging. I don't remember what bug we were dealing with specifically, so let's just get our terminal set up. So CD to main for all of these. Now we can go back. Oop, let me make sure my extensions first are. Yeah, there we go. See, Pylance needed to be restarted. I don't really know exactly why they need to be restarted so often. Why do VS Code extensions need to be restarted so often? Gotcha. Okay, yeah, so there's mainly due to updates or updates to things that those extensions are dependent upon. Okay. So let's go ahead and, well, let me look at things to do. Figure out a way to remember. Oh, okay, I remember. We were actually gonna work on the waiting other player bug, which is this is a bug that's been around forever, about 10 to 15% of the time. It seems higher now, honestly, since we like refactored the data transfer system. It seems more like 20% now, honestly, like, or maybe higher. By the time when both clients start up, the first client still says it's waiting for the other player and nothing ever happens. And like we kind of got distracted by, like, we were still tidying up other things. Okay, we have a unterminated f string literal, so we need to go fix that. Let's see. I see. Okay, so this is server and then line 881. Let's go to 881, and yeah, we forgot to close that. Alright. Okay. So now we have okay, I made a little mistake. A little mistake. What line is that? 368. Okay, we put an extra bracket. Silly goose. Okay, there we go. It's running now. Let's crank up the client script. Client 1 script. Okay, now let's do client 2. Okay. Hey, This is weird. I don't think this has ever happened before. This is, yeah, this is... Oh, hey, wait. Am I tripping? I think I probably hovered over the wrong window, but it looked like it changed to what is your name and then changed back. But I think what happened is I actually... Okay, yeah, I hovered over this window and then moved back down. Gotcha. Okay. So this time, it looks like client 2 is the one that's allowing us to put in our name, and client 1 is waiting other player to join the server. So this, I don't think that's ever occurred before. But I think nonetheless, this waiting for the other player to join the server issue for client 1 is probably like the same issue. You know what I mean? It's probably the same bug that's causing this weird behavior. Um, so I'm just gonna take a little gander at our terminal output real quick, see what we got going on with this. Okay. Yeah, so this right here, this receive verification is for this change attribute list. Okay. Then the draw one, then we send that change attribute list out. Okay. Okay, so what I'm noticing off the bat right here is we have client one thread after the draw one from the main thread is sending the change attribute list which consists of only this single tuple, which is one data point change, and that's game state, and it's being changed to the draw one. Okay, and then we have the expect counter or the apply counter as 1. And then we have client 2 doing the same thing. but it's sending with the apply counter of 2. But why would the apply counter be 2 when we have not yet received a data point change associated with apply counter 1? So this is server, client 1 is receiving from the client side, client 1. Game state waiting other player, okay. And then we have the draw 1 on the main thread. Then we have serve pi client 1 is sending change attribute list with the apply counter as 1. And that should be correct because that's the first thing being sent. And this is going to be C1, C1. This is going to be 1 to 2, 2 to 1, 2 to 2. So this is 1 to 1 is 1, and that's correct. But then when we get to client 2, it's doing the same thing, sending the same data. For some reason, it's showing that this is 1 to 1. It should have incremented 2 to 1, which is this one right here. So I think we incremented, it's incrementing the wrong one. I think so, dude. I think this is incrementing the wrong thing. So I think I'm gonna have to review the apply counter logic, and that's in the data transfer function, which is in the changed attribute list file. So yeah, we have, this is always 1 to 1. So for some reason it's incrementing the wrong counter. Yeah, so the reason that it's 2 is because it's incrementing the C1 to C1 apply counter. Because it was 1 for when 1 sent to 1, which is correct. But then it used 1 to 1 again when it was supposed to be using 2 to 1. So this is 1 1 1 2, and then this is 2 1. So this is the one it should have used. And then apparently it did the same thing here. It's got 3 and then 4. Now this 3 and 4 increment is correct, but then for 2, so this may be our issue here, is the expect counter is not matching the apply counter. So then we have it go from 2 to 3 to 4, and then right here for this data change, it uses 2 to 2. And then it's using 2 to 2 again. Okay. So what I'm also noticing is I don't see where it is sending in terms of the other client. Now it may not be sending because this is a game attribute, that's a game attribute, and that's a game attribute. Okay, so it's not sending in terms of other client. I just want to make sure that it would. So let me look. This is going to be on server side. Okay. So wait, 817. What is this versus 817? Okay, so this is the send section. Okay, they're just if and else. Got you. Okay. Okay. Okay, I'm following all this so far. Now this is send, and then we want to put other client first. Other client. Okay, so we do have that coded in. I just wanted to make sure that was there. So let's put that there. And this can be changed to current client. And this is just going to be Chatly. Okay. Yeah, so it's working correctly. It shouldn't have sent this to the other client because the tup was equal to game. Um, so it removed all of them and didn't send it to the other client, which is correct. So this all should have been incrementing the 2 to 2. But for whatever reason, it incremented 1 to 1, then it incremented 1 to 2 to 2, and that is correct. And then it incremented 2 to 2. But for some reason on this first one, it incremented 1 to 1. Progression text input active. So let me go real quick and check change attribute list. And we're gonna check the logic here. Okay, the apply counter logic, because that's what's wrong here. Transferred game adder. So let me make sure transferred game adders is correct, because I had an issue like this before and I forgot to put a comma in my tuple after one of the entries, and it was putting the two strings together, so it was looking for those two strings, those two attributes weren't working correctly because I forgot to put a comma there. Okay, so let me check all these. Game state is there. Progression text is there. So the one that didn't work is there. And then text input active is there. Okay, so it's not that. So let's look at the data transfer function specifically. Okay. So if SS or CS is equal to SS, which it would be in this case, cal object is equal to C1 change attribute list. Cal object is equal to C1. If cal object is equal to C2 change attribute list. If adder name string not in transferred game adders, then it would be C2 to C1 apply counter and then C2 to C2. Okay. Right, so that's all right so far. Okay, let's see. The game state. This might be in the game state. That might be the issue. So let's go to game state. Try to find. Self.changed attribute list. I'm confused though, because doesn't it change the... So it's showing that it uses self.changed attribute list. Let's see, line 488 or 478. Okay, now let's go and find the self-change attribute list real quick. So self ID is equal to 1. Okay. Okay, game 1, game state setter. Okay. I have game 2, game state setter. Okay. So in this case, the change attribute list should be the C2 change attribute list. We just verified that. Just verified that ID is 2, and we verified that the if the ID was 2, then the change attribute list should be C2 change attribute list. Okay. Now, in this file, if we pass the cal object is equal to C1. Oh, I know. Well, hold up. Since it's incrementing this apply counter, that means it's gotta be going right here. Because this is the only... Okay, yeah, it's not that. I was just... Maybe it's that, but that's not the problem. So it's the only place that it could be going to increment that apply counter would be right here. Which means it must be entering into this if as if the cal object we passed was equal to the C1 change attribute list. But how could that be the case? How could this be the same if it's different? I don't understand this. It doesn't make sense. Python list equal to another list. You can check if two lists are equal using the when you use is equal to put them towards an element by element comparison. For the list to be considered equal, they must have the same number of elements, the same elements in the same order, and the same values for each corresponding element. Yeah, and I clearly passed the correct ID to them when they're created. So that's not the issue. Ah, this is almost certainly means that the cal object being checked here is considered equal to the C1. But if it is indeed the C2, so I have a couple questions. First of them is, I already looked this up before, but does passing an entire object class instance versus passing in an integer ID take more, have more overhead costs? Passing an entire object versus passing an integer ID involve different considerations regarding overhead performances, breakdown potential overhead costs. Passing the entire object, passing class instance involve copying the reference to the object, while this typically efficient. Okay, so now I'm thinking about the importing thing and how we're importing the object. If my understanding is correctly, since we're importing change attribute list into game, okay, we're then modifying that list or passing that list okay. I think I understand. At the time that this function gets called, apparently, both of the C1 change attribute list and the C2 change attribute list are considered to be empty. They're both considered to be empty. That's the issue here. So since they're both considered to be empty, they are they're considered equal. Now, the thing that gets me though, okay, I see. Ah, okay, so I'm seeing what's happening here. So on client 1 thread, it populates the change attribute list when it makes the data change for game state. But then since it sends it, it subsequently clears that change attribute list again. So now it's working, now that C1 change attribute list is empty, okay? And this is assuming like all my import logic and everything is correct, which I think it is. I'm pretty sure like I tested all this stuff and made sure it was right. But, so I'm going to assume that it is correct. So, in that case, this C1 change attribute list is then emptied after it gets sent, because that's how it works. We empty the change attribute list after we send the data from it. And then, since C1 is considered empty, and C2 is empty because it has yet to have any data appended to it, when we run this function call here in change attribute list, data transfer function specifically, it's checking this C2 change attribute list against C1 change attribute list, because I'm quite certain we are passing in the correct object, which is the C2, and it's comparing it against the C1. Now since C1 is empty at this point and C2 is empty at this point, they're considered equal to one another. So this is a design flaw. This means that there's implications. This is this would be a disaster all over, because anytime this function call gets run and it compares the C1 against the C2, all that has to happen for them to be considered equal to one another would be for them to both be empty. And since they're emptied every time every cycle basically, they're populated, then they're emptied, then they're populated. They're like a can. They hold, and then you dump it, and then so like if you eventually they're both going to be empty, and that's going to happen fairly often. So we can't compare them based on equality with each other. We instead would have to compare them based off of, like, really all we need to know is the ID, basically. We need to verify that it's really simple. We just need the ID. We need like an integer rather. We don't necessarily need the ID. We just need an integer. So what we're gonna have to do then is we're gonna change this function to instead. So I'll look up every instance of cal object, and this is going to be changed to cal object integer. So let's say cal object int. Um, and we're gonna change this first because once we change it, it's gonna move to the next one. It's gonna move further along down the screen. So it's gonna be the object integer to which the caltube 1 or 2 depending on C1 or C2. Very simple. To which the caltube will be added. Which determines the or we'll just say that determines which change attribute list the caltube will be added to. Sorry. Read that again. Cal object. The integer 1 or 2 depending on C1 that determines which change attribute list the caltube will be added to. Yeah, perfect. So let's change that to cal object int. Now we're going to change this parameter to be called cal object int. And now this line is going to have to be changed to be we're going to be checking just for 1 instead. So if cal object int is equal to 1, so this is going to be cal object int is equal to 1. Okay. And we actually don't need this printout anymore because I think I figured out the problem. Okay, now this one is going to be 2. We're going to change this one as well. Okay. Now we have calculus function. We're going to pass in the cal object int. And what we can do right here this we'll do it like this. We'll assign the cal object right here equals C1 change attribute list, and then if it's 2, the cal object is going to be C2. Now this is what I'm concerned about. So since we just made that change, wait, did I not just, okay, so did I not change that? Apparently not. Okay. Okay, so here's my concern, and I'm not sure if this is gonna work. It should work. I feel like it should, but what happens is, so we're importing the change attribute list into game, we're then modifying an attribute of game. And in that modification of the attribute in the setter, we are passing in the ID, which references the correct change attribute list. Now, when we call that function, this function exists in this change attribute list file. So it's going to run this function, and then based on that integer, we're going to assign the cal object to the C1 change attribute list or the C2 change attribute list. Now, the well, yeah, okay, so actually, yeah, this isn't a concern. I mean, it shouldn't be a concern because I was worried about the C. My concern is that the C1 and C2 change attribute list, from the perspective of this function call, is going to be the same C1 and C2 change attribute list from the perspective of outside of this function call, outside of this file. And I'm pretty sure it will be, because I went over this, and the two key differences here are between mutable and immutable objects. If you have an immutable object and you import it to a file and then you modify it just by importing it as the variable name, like from this file import x, and then x is in that file set to just 1. If we then import x to another file under that format and then modify x, it doesn't actually modify x in the original place. You're just reassigning x to a new value in that other file. But if the object is a mutable object type, if it's a list or a dictionary or a tuple, well, a list or a dictionary, not a tuple, because tuples are immutable. It's very important. If it's a mutable object like a list, which this is, then when you import that object, it is the same object. And when you modify it in that place, it gets modified in the original place. Which should mean that when we modify it, and then if we modify it from change attribute list pi, and then access it in game pi, there should be the same thing. It should be the same object. And we tested this. I remember testing this. Let me just ask again. Python, if you import a mutable object list into a file, modify the list from the via a function call if you import a mutable object into file 1, and also import a function from, if you import a mutable object list, we'll say from file 2 into file 1, and also import a function from file 2 into file 1, and then modify the list. Let's say import a mutable object, we'll just call it list 1. Modify the list 1 via a function call and we'll call import a function, and we'll just call it F, and then modify the list via a function call F made from the file 1 will the list 1 be modified in from both the perspective of file 1 and file 2? Yes, if you import a mutable object like a list from one module into another and then modify that mutable object through a function call, the changes will be reflected in both modules. This behavior arises from the way Python handles object references. Importing a mutable object. When you import a mutable object, you are essentially importing a reference to that object, not a copy of it. Therefore, with file 1 and file 2 for the same underlying object, modifying the object, you modify the object via function call directly, you're modifying the object both file 1. This means the change will be visible in both modules because there is only one instance of the object. If you import a function from file 2 that operates on the mutable object and you call this function for file 1, the function will operate on the same mutable object that both modules share, thus any modifications made by this function will be reflected wherever the object is accessed. Gotcha. Cool. So my understanding of this is correct. So I don't need to be concerned. My concerns are invalid. I just cleared that up. I just wanted to triple check that. Better safe than sorry. Now, what we have to do here, since we made this change, is we can leave this cal lock list function as okay, so cal object's not going to be assigned though for CS. So we always need to check if cal object, what cal object int is. So we could move this to the top on the outer indentation level. Yeah. Yeah. So we can go ahead and well, we still have to check it again though. Right? Or we can check it first. Yeah, we can restructure this so that on the outer level we're going to check if cal object int is equal to 1. Then this is going to get indented. Okay, now I think I know what I'm gonna do. I'm not gonna do it like that, because then if I do it like that, we're just gonna have to check if SS or CS again. Because I would move this to the outer level, but then that means I would have to check if SS or CS again. It's not a huge deal. I mean, that's fine actually. I'll just do that. So this is gonna, and this will be if SS or CS is equal to SSS. Then we would handle this lock. Okay. Okay, but then I would have to duplicate this code, because I would have to check it twice instead of once because of the way that it's structured. So I think I'm gonna just, yeah, I'm gonna go back to how I had it. So we're just gonna do it like that, and then we're gonna check this, and then we're gonna assign the cal object equal to C1, change attribute list, and then else, which is if cal object is equal to cal object is going to equal C2. Yeah. So now then we have if SS or CS is equal to SS, if cal object n is equal to 1, then we have the lock, which is C1 cal lock. Okay, gotcha. This is all fine, and then we only have to check this once, and we have cal object assigned to be passed to the cal lock list function and to be appended to directly. Okay. Yep. Okay. So that should be good to go, but now we have to change every instance of let's see. We have to change every instance of Yeah, this is gonna work now, but we still have to modify all instances of this function call so that instead of passing in the cal object, we have to pass in the cal object int. So I'll put break 12, let's put 1203. Then I'm gonna put have to modify all instances of below function call. So we are passing the int instead of the actual object. Right. Okay, so I'm gonna go ahead and go to the gym, and we'll finish the rest of that. Come back. 1203, 1052 to 1203. Continued testing and debugging. Discovered a bug and implemented 100% of the fix for it. And then we're gonna come back from XX and we're gonna continue. So I'm just gonna go ahead and quit right now, and yeah, I'll be back in like an hour and like probably 2 hours, honestly. I need to run an errand. So yeah, anyway, see ya.